Hey there students, how's your day been going? I want to welcome you now to iTTV, and my name is Mr. Joel, your tutor for mathematics in Form 4. Alright guys, today we'll be doing lesson 2 of chapter 2, which is quadratic expressions and equations. We have learned that quadratic expression is an expression in the form of ax squared b plus bx plus c. And now we are going to learn how to form a quadratic expression, and that is the lesson for today. Forming quadratic expression by expansion of two linear expressions. When two linear algebraic expressions with the same variable are multiplied, a quadratic expression is obtained. Alright, we have learned a quadratic expression by itself, but where does this quadratic expression come from? Well, it comes from a multiplication of two linear algebraic expressions. So what is the relation between linear algebraic expressions and a quadratic expressions? Alright, the relation is one quadratic expression can be obtained when multiplication of two linear algebraic expression occurs. So to put it quite simply, when we have two linear algebraic expressions, how do we get one quadratic expression? It is by the process of multiplication, which is more commonly known as expansion. So when two linear algebraic expressions are expanded, they will form one quadratic expression. The quadratic expression formed can take one of the following forms: ax squared plus bx plus c, ax squared plus bx, or ax squared plus c. So when you form a quadratic expression, when you multiply two linear expressions, it can be in any of these three forms. All of them are still quadratic expressions. But note that a, b, and c in either of these three forms cannot be 0. They can take any other number. Alright, now we're going to learn and discuss together how do you get a quadratic expression through the process of expansion. Alright, and for that we're going to discuss 4 examples on the board. Now, we have 4 examples here. Each of them is a product of two linear expressions. How do you know it's linear? Remember, linear is 1 degree down from a quadratic expression because the highest power of the variable in a linear expression is 1. So take example A. 3x multiplied by x plus 2. Alright, 3x is one linear expression, x plus 2 is another linear expression. So when we expand them, we will get a quadratic expression. Alright, how do you expand? You must expand and multiply step by step, term by term. The first linear expression has to be multiplied with every term in the second expression. So 3x must be multiplied with x, and we write it as 3x squared. And then don't forget, every term means 3x has to be multiplied also with positive 2. And when you take 3x multiplied by 2, you get positive 6x. So 3x squared plus 6x is actually the quadratic expression that is formed from these two linear expressions by the process of expansion. Alright, now let's take a look at example B. 3x minus 1 is a linear expression. 3x plus 1 is also a linear expression. And when we are going to multiply them, you will obtain a quadratic expression. Remember, be careful, step by step, term by term. Start from the first term in the first expression, 3x. multiply it with the first term of the second expression. So 3x multiplied by 3x gives you 9x squared. Move on systematically. 3x multiplied by 1, positive 1, which gives you positive 3x. Now, this has already been done. The second term, which is 1 in the first expression, needs to be multiplied with every term also in the second expression. So negative 1 multiplied by positive 3x gives you negative 3x, and negative 1 multiplied by positive 1 gives you negative 1. And then simplify the expression if can. So 3x minus 3x is 0. So the quadratic expression that is formed from these two linear expressions is 9x squared minus 1. Let's move on to C. Remember, forming a quadratic expression from expansion. When you have already identified two linear expressions, you have to multiply term by term. Remember, do not go without a system. Okay, don't just take this and multiply with this or this with this. Okay, in any order you like. Okay? In order to avoid mistakes, go step by step. So always begin with the first term of the first expression multiplied by every term in the next. So x multiplied by 5x will give you 5x squared. Write them down. Okay, draw the arrow so that you will see x multiplied by negative 2 gives you negative 2x. Okay, and then the second term of the first expression, minus 1 multiplied by positive 5x, negative 5x, and lastly, negative 1 multiplied by negative 2, negative, negative, positive 2. Alright, remember, you need to simplify the quadratic expression to the simplest manner. And you can simplify minus 2x minus 5x because it gives you minus 7x. Alright, you take note, the quadratic expression that has been obtained is in the general form of ax squared plus bx plus c, which we have learned in the previous lesson. So this is just how do you obtain it from expansion. Alright, in D, one more, one linear expression, another linear expression. Remember, forming a quadratic expression through the process of expansion or expanding the terms. So step by step, 1, 4 multiplied by x will give you 4x. Alright, 4 multiplied by 2 will give you, both are positive, positive 8. Alright, negative x multiplied by x, negative x squared. And negative x multiplied by positive 2, negative 2x. Okay, and then simplify, and always put the quadratic expression back in the general form, which means that the x squared has to be first, followed by the variable x. So 4x minus 2x, positive 2x, and positive 8. So all these are the result of expanding any two linear expressions, and the result is always a quadratic expression, which means one of the variables will definitely have an index of 2. The first useful expansion, a plus b square equals to a square plus 2ab plus b square. The second useful expansion, a minus b square is equals to a square minus 2ab plus b square. If you look at both of these expansion identities, you can take note of something very common. That is, both of them has been squared by itself. So if you come across two linear expressions that are identical, which means they have to be multiplied with each other, you can use this identity to speed up the expansion process. And there's one more useful expansion tip, which is a plus b multiplied by a minus b. When this occurs, look at the difference. A and b is the same. The only differing thing is the sign. One is positive, one is negative. So the result of this expansion is just take the square of a minus the square of b. When you look at the question and you are asked to simplify, it means you must expand and perform necessary operations such that the quadratic expression that you obtain must be in its simplest form. Alright, unless you get the simplest form, it is not the simplest that it can be. Now, look at this expression. You have 8m squared minus 2m minus 3 squared. Okay, first step, you have to expand this part, 2m minus 3 squared, because we cannot perform the operation of minus unless we expand this. Okay, and we have learned just now 8m squared minus 2m minus 3 squared is actually 2m minus 3 multiplied by itself. Okay, so now before you can minus, this needs to be multiplied first. Okay, so follow me. 8m squared minus. Okay, now remember we have expanded quadratic expression just now. The whole idea is term by term systematically. 2m multiplied by 2m, and you will get 4m squared. Next, systematically 2m multiplied by minus 3m. Be careful of the sign. You will get negative 6m. And then now it is the turn for 3. Minus 3 multiplied by positive 2m, negative 6m, and finally minus 3 multiplied by minus 3, you will get positive 9. Okay, this part here can be simplified further, so it becomes minus 12m plus 9. Alright, once the quadratic expression has been obtained, we can open up the bracket. But when you open up the bracket, do not forget that there is a negative sign outside and it affects everything that is in the bracket. So it is minus 4m squared plus minus minus plus 12m, and then minus positive minus. Okay, so the very last line, the simplest form that this expression can get, 4m squared plus 12m minus 9. Alright, so now, once you see the quadratic expression is the simplest form, you have achieved what you wanted to. This whole expression has not been simplified. But in order to simplify, you need to go through the expansion process. Remember the expansion process? Step by step, alright? And term by term. Where a minus b square is a square minus 2ab plus b square. Alright, if you practice, you will get it. Okay, so the final answer is the same as shown. What is the use of all this? As we have learned before, mathematics in life for a quadratic expression has to do a lot with algebra. Alright, for particularly quadratic expressions, the use of it is to form quadratic expressions based on specific situations. And what does it mean? Because many times, alright, in life, when dealing with situations such as solving problems, mathematical problems, you will have to come across values that are yet to be known, and you call this an unknown. An unknown is always represented by the variable x, and once variable x is involved, it has to do with algebra. And if the variable x has a degree of 2, it is a quadratic expression already. Alright, so now, what are the steps that are needed for us to form quadratic expressions based on specific situations? Step 1. Choose an alphabet if not given, to represent the variable in the given situation. What does it mean? It means that if the variable has not been labeled by any alphabet, you decide what alphabet you want to label the variable as, X, Y, Z, anything you want, okay? And in step 2, express the other variable in terms of the alphabet chosen earlier. Alright, we'll come to that later. And step 3, form the quadratic expression based on the given situation. So you must be alert to see how can you form that quadratic expression. Alright, now let's look at our first example, yeah? Given that the height of a triangle is 3 centimeters shorter than the base, express the area in cm square of the triangle in terms of x, where x in centimeters represents the length of the base. Alright, look here, what object do we have? We have a triangle. And the height is 3 cm shorter than the base. Alright, try to imagine the height of the triangle is 3 cm shorter than its base. Alright, now what do you need to find and express? The area of that whole triangle in terms of x, where x is in centimeters. So what is the most important thing? It is hard to imagine, right, without sketching a diagram. So let's look, the most important thing, sketch. Let's look at our solution here. If there is no diagram, you sketch the diagram yourself. So now I've sketched a triangle here with the length and the base and the height, okay, yet to be known. Alright, from the question and given information, all we know that the length of the base is x centimeters. That is what is given. Do we know what is x? No. So it remains an unknown and a variable. Next, what else do we know from the given information? The height. Since the height is 3 centimeters shorter than the base, so now put it logically in operations, it is x minus 3 centimeters. Alright, and since the area of a triangle is half times base times height, take half, multiply it with base, which is x, and multiply it with length, which is x minus 3. So once expand the two linear expressions to form a quadratic expression, and it represents the area of the whole triangle. Alright, now why don't you do this yourself? It's a quick test and expand the following linear expressions. Alright, now a quick test for you. Expand the following expressions, okay? Alright, give you some time. Alright, I'm sure you have your solutions by now. For A, 2x multiplied by x minus 5, okay? And you should obtain, remember, term by term, 2x squared minus 10x. Alright, B, 4x minus 3 square. Okay, you can use the useful expansion identity earlier, but anyhow you do it, either step by step or using the expansion, you should get 16x square minus 24x plus 9. And C, the product of 6 minus 5x and 3 plus 2x is negative 10x square minus 3x plus 18. Okay, what about number 2? A slightly longer expression. Simplify it. Alright, I'm sure you have. Simplify 2m plus 7 multiplied by m minus 6 minus m times 2 plus 5m. You should get negative 3m squared, negative 7m, negative 42. Alright, some more questions for your practice. Expand the following expressions, yeah? Alright, for A, what is the result of negative 3x multiplied by x minus 6? Minus 3x squared plus 18x. For B, 4 minus 3x bracket square 9x squared minus 24x plus 16. And for C, you'll obtain the quadratic expression from 6x plus 1, 2 minus x, and it is minus 6x squared plus 11x plus 2. Alright, now simplify the following quadratic expression. Okay, so we have learned this just now, how to simplify it. Remember the few steps. Okay, this is a quadratic expression that needs to be simplified, but in order to simplify, you need to expand a few quadratic expressions by the side in order to perform the operation. So look at this, this is already by itself, doesn't need to. This part needs to be expanded. Okay, so do not do it one shot. 3p squared plus, alright, now this part here needs to be expanded, and it is a product of p and p minus 2. So p needs to be multiplied by p, which is p squared, and p needs to be multiplied with negative 2, which is negative 2p. Right? Once they are all in brackets without any multiplication needs to be done, you can simplify it by opening up the bracket. Since it is positive, no signs have changed. Okay? So you will obtain the quadratic expression 4p squared minus 2p. Alright, and the answer is there. Alright, the second exercise. Expand and simplify the following quadratic expression. Okay, so rewrite it on the board. Alright, this is slightly a longer quadratic expression, but be careful. Simplify, remember, step by step, term by term. So this first part here consists of a product of two linear expressions. Remember, two linear expressions when expanded will give you a quadratic expression. Here there is another two. So this is actually a subtraction of one quadratic expression, which we'll get later, from another. Okay, so step by step. So 2t multiplied by t, 2t squared, minus 6t, positive 5t, minus 15. Okay, keep it there. Keep the sign which is negative. Okay, and rewrite a bracket first. Okay, because this side will give you another quadratic expression, which is positive t, positive 7, minus 3t squared, minus 21t. Okay, now when this occurs, open up the bracket. Minus t, minus positive minus 7. Be careful of the sign, because the sign will determine whether the quadratic expression you get is true or not. Alright, so the final answer, since it is long, simplify until you cannot simplify anymore. 2t squared plus 3t squared is 5t squared. Negative t, negative 2t plus 21t is plus 19t, and negative 15, negative 7, negative 22. So you actually obtain a quadratic expression and simplify it by simplifying term by term, alright, until you get the final answer. Alright, our last exercise for today. Alright, it has to do with forming a quadratic expression based on a specific information. Alright, let's read together. A cuboid has a square base, and the height is 2 cm longer than the length of the base. Find the total surface area in cm square of the cuboid. Alright, use that hint. Let the length of the base be x centimeters. Alright, in order to do that, remember what can you do? Alright? Sketch a cuboid if you do not have the diagram. Okay, so I have a cuboid here, and it tells me from the question and given information that the cuboid has a square base. That means the length and the width of the square base is the same, and it is x cm from the hint. So if the length of the base is x cm, the width is also x cm. Alright, and what is the height? The height of this cuboid is 2 cm longer than the base. Alright, think. If the base is x and 2 cm longer than the base, therefore the height of the cuboid must be x plus 2 centimeters. Alright, now find the total surface area of this cuboid. Okay, now how many surfaces does a cuboid have? 6, right? Top, bottom, right, left, front, back. So you need to actually sum up the areas of every surface. Okay, so let us take the first two surfaces, up and down. Okay, so this surface has a area of x by x, x squared, and since there are two such surfaces, the area will be 2 times x squared. Now let us take the sides of the cuboid, which is the left and right side. It will have an area of x by x plus 2 cm, and since there are two such surfaces, it will be 2 of such. 2 is for two surfaces. And one more, okay, front and back also has a same area of x by x plus 2, and since there are two surfaces, 2x by x plus 2. Alright, so the area of this cuboid is actually can be simplified to a quadratic expression when we expand and perform the necessary operations. Alright, so step by step, okay, until you can add. Expand, expand. Here also expand and expand till you get. Once there are no more multiplication of any two linear expressions, add the constants of x squared to itself. So there is 2 of x squared plus 2 of x squared plus 2 of x squared. This results in 6 of x squared. And there is 4 of x plus another 4 of x, 8 of x. So actually the area of this whole cuboid in terms of x will be 6x squared plus 8x centimeters squared, since we do not know the length of x. Alright, so the answer is there. Alright, so with this exercise, we have concluded our lesson for today. And lesson 2 of chapter 2. What have we learned today? We have learned how to expand two linear expressions to form a quadratic expression. And we have also learned how to form quadratic expression based on specific situations. Alright, that's all for today. We will continue with our lesson on quadratic expressions and equations in the next one. Thank you and goodbye for now.